5.4 talks about integration formulas and net change theorem. Net change theorem states the new value of changing quantities equal to the initial value plus the integral of the rate of change. That's been the new value. That would equal the initial value plus the integral of the rate of change. Now, the integral of rate of change we could use to figure out displacement or distance. And if you just subtract this from both sides, pretty much you go back to the fundamental theorem of calculus, part 2. Nothing more. Now, I'll elaborate really quick how to use this. Now, Pasadena City College students, you should skip this part. Skip over everything I'm going to talk about now until I start number 212. So 208, 210 doesn't apply to you and it's not on your homework. If I take a derivative of e to the kx, where k is a constant, that's e to the kx times k. So if I integrate e to the kx dx, that's e to the kx. When you take a derivative, you multiply by k. To undo that, which is the antiderivative, you divide by k. That's a shortcut for you to figure those out if you're off by a linear constant. That's one. That's going to apply to 208. 210, I have to show you something else really quick. So if I'm integrating this, you could say that is e to the 2x. When you take a derivative, you multiply by 2. So when you take an antiderivative, you divide by 2. Minus 1/2 the integral, so the derivative of e to the x over 2 is e to the x over 2. But if you take a derivative, you would multiply by the chain rule by 1/2. So to undo that here, you would divide by 1/2. And of course, you could cancel those and say, hey, that is e to the 2x over 2 minus e to the x over 2 plus c. Again, City of Knowledge student, Pasadena City College students, you really don't need to worry about this part. That comes in your second semester calculus. And Cal Poly students, don't be concerned if you're not fully getting this. When we get to section 5.6, we talk specifically about those in full details. Here is just an introduction. Thought I'll take this out of the way since this is a short section. Also, if I work this out, this is the integral of x over x squared minus 1 over x dx. That is the integral of 1 over x minus x to the negative 2 dx. And what do you take a derivative of to get 1 over x? Natural log of x. I need to modify that a bit in a minute. Minus, add 1 to the power. Divide by that. So my answer would be actually, so we take a derivative of natural log of x, we get 1 over x. Now there's a small modification. I'm going to show you why is that from now on. We took a derivative of natural log of x. Keep in mind, absolute value of x is x if x is bigger than or equal to 0, and if the inside of the absolute value is negative, that would be negative x. So if I take a derivative of natural log of absolute value of x, that's the derivative of natural log of x if x is bigger than 0, and natural log of negative x if x is less than 0. We can't have x equals 0 because natural log has a restriction in the domain. So if I take a derivative of this, that's pretty much 1 over x if x is bigger than 0, And this will be 1 over negative x by the chain rule times the derivative of a negative 1 if x is less than 0. That becomes a positive. So you notice if you take a derivative of natural log of absolute value of x, you get 1 over x regardless. So now when you want to undo this, when you want to integrate 1 over x dx, from now on we say that is natural log of absolute value of x plus c, of course. All right, this is a definite integral. Now we're talking about this part, the net change theorem. If they say integrate, that's called displacement. And we'll elaborate on that once we get to these problems. But for now, well, what do you take a derivative of to get x? That is x squared over 2. What do you take a derivative of to get negative sine? That's positive a cosine of x. Derivative of cosine is negative sine. Evaluate it from 0 to pi over 2. Or you could say that's f of pi over 2 minus f of 0 by fundamental theorem of calculus, where capital F is pretty much what I just found. Or you could just write it like this. Plug the pi over 2 in. That's pi over 2 squared over 2 plus the cosine of pi over 2 minus f of 0. That is 0 over 2 plus cosine of 0. So altogether, I'm looking at pi squared over 4. And half of that is pi squared over 8 plus 0 minus 1. And that will be pi squared over 8 minus 1. Or simply, if you want, pi squared minus 8. Now, anything that I box is an acceptable answer on your test, but to match it with the back of the book, that's kind of what you have to do sometimes. No big deal. Now we get to the difference between displacement and area. Displacement is nothing more than, suppose that a particle moves along a straight line with a velocity, that's the given velocity, where you run t between 0 and 6, of course, times in seconds in this case, and distance is measured in meters, not in feet. Find the displacement, and let me show you really quick. If I have the velocity of a train is 50 miles per hour, and if the time frame runs between 5 p.m. and 7 p.m., then if I take the velocity, let this be the velocity, that's 50. And if I chop it off between 5 and 7, let's say that's 5, let's say that's 7. Well, this is 2 hours. This is 50 miles per hour. If you look at the distance, if you look at the area that covers, that is length times width. That's 50 times 2 hours. This is, of course, miles per hour. And this is 2 hours. And of course, that's 100 miles. I know you know that, but what if the train was traveling in such a path and you're interested in finding that area? Well, it's very hard to do because that's not a standard. There's no standard formula for this. So instead, to find the total area, just integrate from 0 in this case to whatever that is. And if I have a function of the velocity, then it's just integrate velocity and you go from there. Or let me reverse the order. If I told you the position of a particle, you take a derivative of that gives you the velocity. So to figure out the total distance traveled by a particle, you would integrate the velocity over a period of time, and that gives you the displacement or the area. If the velocity happened to be positive all the time, then that's simply displacement and area would be the same. But displacement is pretty much with reference to where you started, where are you? So for example, if I was to travel forward, then stop, go in reverse, and then stop. The difference is if I integrate, I should have chosen different than 0, but it's okay. If I integrate, so assume A is bigger than 0 and B is bigger than A. Suppose that's the case. If I integrate from 0 to B, f of t dt, assuming this is the velocity, or v of t, let's go that way, make it easier, official. This is going to take this and subtract this from it, and gives you the displacement. Pretty much where are you with reference to where you started. If I want to figure out, so for example, if I would have traveled 1, 2, 3, 4, 5 miles forward and 2 miles backwards, so positive to the right, east, and negative to the left or west. If I integrate, if this is the velocity function, and I integrate, right, the velocity in this case, and let's say the time frame was 0 to 7 minutes. I was traveling 1 mile per minute, or walking 1 mile per minute, whatever it is. If I integrate that, that's going to say 3 miles. Meaning, the integral will say, well, look, you started right there. Let's say that's your position. To reference where you started, you are only 3 miles away. If I want to figure out how much distance I traveled altogether, I would integrate from 0 to 7, and I'll take the velocity, and I'll just slap an absolute value on it. And what that does, that says, wait a minute, you walked 5 miles forward and 2 miles backwards. That's 7 miles. So absolute value of the velocity will give you distance. And the integral by itself will give you displacement based on where you started, where are you. Now we all know absolute value. You have to really figure out where's the inside the absolute value, positive, or where is it negative. Every time you see this, you have to figure out, well, if the inside of the absolute value is bigger than or equal to 0, I don't need the absolute value. But if the inside of the absolute value is negative, I have to slap a negative in front of whatever was inside of it. That will ensure that it's always positive, which is the definition of an absolute value. So here we are. They're asking for two things. Find the displacement and the total distance. Now, the setup. If I just wanted the displacement, nothing more, that's simply the integral of t squared minus 3t minus 18 dt between 0 and 6, and I'm done. That's all there is to it. So this is going to tell me where are you with reference to where you started. Well, that is t cubed over 3 minus 3t squared over 2 minus 18t evaluated from 0 to 6. That is 6 to the third divided by 3 minus 3 times 36 divided by 2 minus 18 times 2. If you substitute 0 in this case in all of those, you do get a 0. So that will be, oh boy. 6 cubed divided by 3 minus 3 times 18, or 36 divided by 2, minus, I'm getting negative 18. So with reference to where you started, you went in reverse more than you went forward. As far as displacement, based on where you started, you're behind or to the left. If you take east to be positive, you're west 18 miles from where you started. Now, if I want to run the distance, if I want to figure out what the distance is, I'm going to say that's the integral from 0 to 6 is absolute value of t squared minus 3t minus 18 dt. Now we have a problem. With technology, just plug in the absolute value key in a calculator. It will tell you what that is. That's really simple, but we're not allowed to use that yet. Hopefully, one of these days we start doing that. Setup is the crucial part. But if I would go ahead and want to figure this out, I have two options. Either I graph this, or I make a chart. Either way, it doesn't matter which method you choose. You're going to have to take t squared minus 3t minus 18 and set it equal to 0 and factor that. If it factors, that's t minus 6, t 3 times plus 3 equals 0. That's t equal 6 and negative 3. So if I put negative 3 there and 6 there, two ways of figuring this out. The longer way is to pick points, and of course you don't care about negative because you want to start from 0. But if you pick a point between negative 3 and 6, any point just to test the absolute value, you could pick 0. If you put 0 there, that's negative. Pick a point to the right, say 7. If you put 7 in there, well, that's positive times a positive, which is a positive. Or simply, doesn't a parabola open up if these are the x-intercepts and it opens up, the parabola should look like that. Well, it's negative here, positive here, meaning this happened to be going in reverse the whole time. So this is simply the way you would get rid of that, since that's an absolute value and it's negative. You put a minus in front of this. And that's pretty much it. And that will be 0 to 6. And that's going to be negative. Well, we did that already, right? F of, so we did all of that work. Since it's really all positive or negative, all what that's going to be is, oh, that should be a 6. Let me figure out what that is. Oh, 90. So, and it's not always simply the opposite of that, because just it happened to be always negative. The next example will shed more light on it. And the numbers normally are not always this nice. In real applications, things don't work out this nice. Well, let's get this part out of the way. Suppose that a particle moves along a straight line with acceleration. So the acceleration is given by t cubed minus 3, where t runs between 0 and 6. So remember again, if I'm given displacement, distance, if I'm given the position of a particle, if I take a derivative of that, that will be the velocity. And if I take a derivative of the velocity, that will be acceleration. So now, when they say find the velocity and they're given the acceleration, well, they tell you that the velocity at 0 is 3. And the original distance, you're starting at the origin. Okay, very good. Because every time you integrate, you pick initial values. Well, if the acceleration happened to be t minus 3, now what do they want us to find? They want us to find displacement Then they want us to find distance. Well, displacement is simply the integral of the velocity. Well, let's see. If acceleration is t minus 3, then the velocity is the integral of that with respect to t. So the velocity is t squared divided by 2 minus 3t plus the initial velocity. But the initial velocity is 3. So there's my initial velocity. Now to find the distance equation or displacement equation, I integrate velocity. If I take the integral of velocity, that's simply t cubed over 6, that's the position, minus 3t squared over 2 plus 3t plus the initial height, which is 0 in this case. So pretty much that is my position. So they want us to find the velocity, and displacement during the find the displacement and velocity, find the displacement and total distance up to t equals 6, so between 0 and 6. All right, well, displacement is simply the integral of the velocity from 0 to 6. Done deal. Now, the reason I need to find this, if this wasn't 0, I will have to add that to the initial amount. In this case, we'll have the initial position being 0. And what is that? Well, we already figured that out. That's t cubed over 3 minus 3t squared over 2 plus 3t evaluated from 0 to 6. That's 6 cubed over 3 minus 3 halves 6 squared, 36, plus 18. If you plug in 0, in this case you get a 0. That's not always the case. And let me get this really quick. That is 6 cubed divided by 3 minus 3 times 18 plus 18. So the total is 36 meters. Now, displacement is always simple. It's pretty much what the integral gets you. When I want to find distance, I'm going to integrate from 0 to 6 the absolute value of t squared over 2 minus 3t plus 3 dt. To be able to work this out, I need to figure out where does t squared over 2 minus 3t plus 3 equals 0. That's when t squared minus 6t plus 6 equals 0. Factors of 6 to add up. 1 and 6 add up to 7, 3 and 2 add up to 5. This doesn't factor. That happens a lot of times. Use quadratic formula or complete the square. Take half of the middle number, which is 3, and square it. That becomes t minus 3 squared equaling 3. So t will equal 3 plus or minus radical 3. Well, if I do the testing, this is 3 minus radical 3. Radical 3 is about 1.7. So this is about 1.3. And if I take 3 plus radical 3, 3 plus 1.7 is about 4.7. If I pick a point to the left of 1.3, say I take 0, only in the derivative. If I put 0 there, that's simply positive. If I pick a point between 1.2 and 4.7, let's say 2. 2 squared is 4. Divided by 2, that's 2. 2 plus 3 is 5. 5 minus 6 is negative 1. And if I pick 5, 25 over 2 plus 3, that is 15.5. And of course, you could pick 10 if you want. 100 over 2, obviously that's possible. Well, here we go. From 0 to 3 minus radical 3, since it's positive, I don't need the absolute value. But the fact that it is negative, I put a minus in front of 3 minus radical 3 to 3 plus radical 3 of t squared over 2 minus 3t plus 3 dt. And since from 4.7 to 6 it's positive, I add from 3 plus radical 3 to 6 of simply t squared over 2 minus 3t plus 3 dt. So pretty much it's already figured out what that is. We already know it's going to be. So we know that f is t cubed over 3 minus 3t squared over 2 plus 3t. So basically, this right here will be f of 3 minus radical 3 minus f of 0. When I get to this part, I'll have a minus f of 3 plus radical 3 minus f of 3 minus radical 3. And when I get to this part, it's simply f of 6 minus f of 3 plus radical. And as you see, this is just busy work. You could just figure out what these numbers are, and that answer better be positive, and that's going to be in meters. Now let me work that out on the side. I don't want to take lecture time to do that. That turns out to be altogether 4 3 meters, or 4 times 1.7, whichever. And here's another problem. A ball is thrown upwards from a height of 3 meters. The initial height is 3 meters. At initial speed, the initial speed is 60 meters per second. Acceleration results from gravity is negative 9.8 meters per second squared. You're expected to remember that for physics and other courses, even throughout the rest of this course. Every time you drop an item and the only thing that's working on it is gravity, neglecting a resistance, you assume the acceleration is negative 9.8 meters per second squared, and if it's in feet, that's negative 32 feet per second squared. Solve for the velocity. To find the velocity, you integrate acceleration. That's something that we know already. That's negative 9.8 t plus the initial velocity, the constant. Well, they told us the initial velocity was 60. So we know that the velocity function is negative 9.8 t plus 60. That tells me the velocity anywhere I am. Now, if I take the height or the position is the integral of velocity. Well, that is the integral of negative 9.8 t plus 60. Start writing that right. That is negative 9.8 t squared divided by 2 plus 60t plus the initial height. But I know what the initial height is. That's 3. So I know that the height is negative 4.9 t squared plus 60t plus 3. That tells me the height at any given time after it has been thrown. And that's pretty much it for this section.